Hello everyone and welcome to this presentation on AI-moderated decision-making. In this work, we show procedures to capture anchoring bias in sequential decision-making tasks and how to subsequently mitigate it with machine learning. When making decisions sequentially, we often inherently compare the current instance to be evaluated by the decisions that we made before that. For example, this can happen when reviewing papers in a row, grading students, or evaluating people for jobs or college admissions. Imagine a scenario where you evaluated and rejected 3 unqualified students in a row to be admitted to a college program. Then, if you evaluate a specific file X, you might be unconsciously biased towards admitting that student. On the other hand, if you'd just seen 3 highly qualified students and admitted them all, you might be unconsciously biased to reject the same particular file X. This natural but flawed behavior is called the anchoring bias and has an impact on the correctness of the decisions as well as individual fairness, which states that similar files should be given similar decisions, irrespectively of the order in which they were reviewed by a human. Our work shows 2 ways of mitigating this kind of bias. First, for use cases where the decisions were already made, we find that we can flag potentially incorrect decisions for re-review, where the anchoring state of a reviewer is captured within our probabilistic model. On the other hand, we find that we can mitigate bias prospectively, before decisions were made. We show that we can learn when a reviewer is biased and sample the next instance for review accordingly. Simply changing the order of files to be reviewed requires no adaptation of the task setup visible to the user. We compare all of our methods to the conventional procedure of evaluating instances in random order within different crowd studies. Our work is based on 2 sequential decision-making datasets. First, we use decisions made for college admissions, where reviewers evaluate student features like GPA or recommendation letters. Over 26,000 decisions were made by 117 unique reviewers. Second, we use a sequential evaluation of product reviews, where over 3,500 decisions were made by 90 unique reviewers. For the college admissions data, the decisions were already made. But for the product review procedure, we had the opportunity to collect data from different orders of review instances. First, we collected data on reviews in random order. Second, we heuristically alternated positive and negative reviews, depending on which decision was made beforehand by a reviewer. Third, we used a learned strategy to select the next instance to be reviewed, based on a learned anchoring state of this particular reviewer. The right-hand figure shows the user interface that was shown to evaluators during our crowd study. When retrospectively mitigating anchoring bias in sequential decision-making, we found that the probability of being anchored can be modeled with an exponential distribution, where we found that it increases up to a certain threshold, and after this threshold, a reviewer makes a biased decision. We found that a logical strategy can correct those potentially biased decisions, which takes into account the biasing state of a human reviewer, a machine learning model decision, for example, made by a support vector machine, and the original review that was made by the human. For this retrospective mitigation procedure, we found that the agreement to final admission decisions made by a meta reviewer increases for college admissions. And we also found that sequential dependencies to previously made decisions decrease. A similar but even stronger effect is found in product reviews, where the agreement to the majority vote compared to the random order evaluation increases by 5%, and sequential dependencies to previous decisions decrease by 0.08. When we have access to the order of the decision-making process within the live process, we show that we can mitigate anchoring bias prospectively before decisions are made. We remember that the goal is to minimize the anchoring state of an evaluator such that the next decision doesn't depend as much on previous decisions. We learn this by modeling the anchoring state with an LSTM neural network and subsequently sample instances in a way that reduces influence of previously made decisions with reinforcement learning. Using this procedure, we find that the heuristic and learn strategy increase agreement to majority vote and decrease the sequential dependencies to previous decisions. We observe that the learn strategy outperforms heuristic evaluation and increases the agreement to the majority vote by 7%, compared to random order evaluation. We also see that there is a slight difference in reinforcement learning algorithms, but the overall agreement is the same for both reinforcement learning procedures. In summary, our work studies anchoring bias in sequential decisions within a real-world study on college admissions and product review decisions. We find that we can mitigate bias post-hoc after decisions were made, as well as in situ within the decision-making process. Our work strives towards increased fairness in decision-making within this setup of sequential decision-making tasks. Please check out our paper for more details.